Welcome everyone to another packed live session. And today I'm joined by Kishore and Yeshwanth, authors of Modern Computer Vision with PyTorch. And we'll be talking about computer vision today. And so we'll also be giving away 2 e-copies of Modern Computer Vision with PyTorch during the session. Just comment with hashtag packed to enter the raffle. We'll have one raffle in PPP. We'll have one raffle in 30 minutes and the other one at the end of the session. Also, add your questions to the chat and we'll try to go through them if we can. So before we start, would you both like to tell us a bit about yourselves?
Sure. Probably I can go first. Hi all, my name is Kishore. I've been in the field of data science and AI over the last 15 years. Started my work with American Express, then moved to Amazon within their supply chain team, and then moved to United Health Group, where I worked across multiple divisions within UHG, leveraging deep learning and also building the data science team over there. And then I started my own company called Evon, and we are now launching a stealth mode, or we are launching a platform coming out of Evon. Outside of work, I've been very interested in this field. With the second edition of this book, I've written 6 books so far and have filed 12 patents that are at the intersection of MLAI and healthcare.
Yeah, I can go next. Yeah, hi everyone, this is Yeshwanth. So I've been in data science and AI for around 8 years. So I started as a mechanical engineer, but I quickly switched to this branch, and I worked as a teacher for around 3 years in the field of AI. And after that, I switched to a more conventional software engineering role, which is where I met Kishore sir in United Healthcare. So we built a few products in the field of computer vision. More specifically, I worked in document analysis and data extraction. And since then, I've been working more or less in data extraction only. Even to this day, I'm working in optical character recognition, followed by document analysis. So that's where I currently stand. So I have written one book, and I have around 4 patents in this field. And outside work, yeah, I'm more interested in exploring tools that help software developers for sort of making their lives easy. So I built a couple of products, open source products in GitHub, and yeah, that's more or less about me.
And do you want to tell us a bit about your new book, Modern Computer Vision with PyTorch?
Yeah.
Go ahead.
Yeah. So this was a product of more or less intrigue and love. So it was there. It was back in the days when we were back in the days of Keras, where there were no good materials out there. We always had to rely on really niche blogs, and even the official documentations were not that great. So these were the days when both Kishore and I got motivated, thinking, you know what, we've done so much work in computer vision. Why not compile all our thoughts and gather them in the form of a book? And that's how the whole process started. And given the success of the first edition and the fast-paced field, we really had the fortune to come up with this edition, where we had the opportunity to introduce not just transformers, but we went somewhat in depth into even more exciting field of stable diffusion. And I believe we've made a considerable progress in trying to demystify um, uh, sort of what is that the beast called as stable diffusion, and how can we try to make sense of the tool, it's not a small architecture to speak about. So we've done really our best to break it into components as digestible as possible. And while breaking it, we also try to come up with really good examples that can actually highlight the importance of each and every component in the book. So yeah, that is sort of my motivation and perspective around the book.
Yep. And I think from my side, I really wanted to write a book that I wish I had when I started my learning journey. So think of, let's say, 2015, when deep learning was taking off. I really wished I had something that contained the chapter 1 and chapter 2 of our current book, where we very clearly explain what is happening under the hood of neural networks. And also we sort of went and built a neural network right from scratch and compared that with, let's say, the framework here, PyTorch, and showed how the models are working. And then again, now I went back to all the way to 2015, and the industry progressed since then, 2015 to 2016, 17, and so on. We had a lot of progress within image classification, object detection, image segmentation, and so on. And that's the kind of progression that we had in the book as well, where initially we would have how the neural networks work, how the image classification works, and then we progressed into object detection, image segmentation, and we've introduced all of them in such a way that if it is a completely new reader, they would be able to understand why certain architectures are built the way they are and what exactly is happening under the hood of each of these architectures. So essentially, this was a book that was written for myself a few years ago. Apart from that, while we have talked about this one, as Yashwant said, there is a considerable progress in this field. So again, being the continuous learners we are, and that everyone should be, we sort of took the challenge that let's try and replicate the same magic that we did back in the first edition, where we broke down complex concepts into digestible ones. And that's the attempt that we have made with the transformer piece that we have introduced in the second version, and also in the latest stable diffusion related frameworks. But then what we have also realized is the field is progressing really fast, and I don't think we'll be able to cover the latest versions in the print version of the book. So what we have also done is we have introduced what we call as supplementary notebooks or supplementary folders within our GitHub repository, so that some of the latest advancements in the computer vision space are covered in our GitHub repository, so that be it the book or the associated repository are always on track, or at least as much as possible, with what is current in the industry or in the research.
Excellent. So everyone, yeah, feel free to add questions into the chat or join our raffle. So I'll start with the first question then. How are foundational models different from generative AI models?
Sure. Again, think of it as a scenario where, let's say, think of the typical scenario where you're trying to do object detection or segmentation. Let's say 3 years ago, when we did not have some of the latest work, be it on self-supervised algorithms or the transformers or segmentation techniques, what people would do is collect a bunch of data and then annotate that data and then fine tune some of the pre-trained models. Think of your VGG16s, ResNets, and so on, and then go ahead, have that algorithm in place. But then what has happened with the large scale training that we have, that is now the revolution, be it in the language side of the world or in the vision side of the world, is that people have figured out that you're able to get zero shot segmentation or zero shot detection by training on large scale data. When I'm essentially talking about billion data points, let's say, think of your segment anything model for a moment. So that is where, when you have trained on such large data, That sort of then becomes your foundational model, where it enables your zero-shot segmentation. Now comes the second scenario where you're talking about generative AI. While the subtle difference that in my view between the two is your foundational models are helping in sort of getting your task done with as minimal data as possible, and the generative AI is helping in generating, let's say, images or generating or answers for some of the questions that you're asking to the to the common with a combination of image and language based on your question and then the image. So essentially, in my view, it's the difference between the task that we are trying to achieve between a foundational model and then the generative AI space. Yeshwanth, anything else that you would like to add?
Yeah, I'll try to summarize in one sentence. I think foundational models, their main aim is to capture the essence of real world, and that can only happen via really extremely large training data. So the more data you pump it, and with the goal of trying to have a model that can do really magical things in the future, that I think we can call it as a foundational model. Generative model is something that uses foundational models to do the said magic, which is what we are seeing every day.
Thanks for that. PPP, yeah, if you mention it, any issues you've had on our sort of Discord channel, and we can get back to you. So yeah, the second question is, which sort of vision use cases leverage generative AI?
Yeah, I can. Yeah, so we have been seeing, as you know, you remember February when OpenAI came up with this model called as Sora, I believe. So it was just taking text and generating videos. So I believe that is like that was the moment, that was the ChatGPT moment for vision models, in my opinion. And that also takes me to the answer. The use cases of computer vision generative models is largely, I think, in the space of entertainment, where you are trying to use your artistic creativity to come up with products or to visualize things which are generally very difficult to do, right? So this was back in the days of animation, when you used to draw stuff that that's really hard to replicate in physical life. That was like a pivot from trying to go from realism to something where into the world of fantasy, where you can start imagining things which you can do with less effort. And I believe one of the use cases, maybe Kishore can add more, but yeah, one of the core use cases in vision generative AI happens to be in trying to visualize and come up with more and more wild use cases that can that where you can which you can share with the world in relatively less time.
Yep. I also see quite a lot of use cases, let's say in my domain, which is in the healthcare side of the world, where there are a bunch of documents. It could be your forms that are filled and you're trying to extract information, where there are large operations teams that are looking at these forms and data into a database. And potentially that is where there is some level of question answering associated. Or in the traditional world, you have a traditional way of fetching the keys and values from these corresponding forms. That could be one scenario. The second scenario, again, is in helping the operations agent. For example, think of a scenario where you are presented with hundreds of pages of documents, and all of these happen to be scanned images. So how do you help the operations agent get their work done faster based on the question that they are trying to answer? So essentially, generative AI can help in getting to the right page faster and also highlighting that information so that the user does not have to sift through hundreds of pages but can get to the page straight away. That's a second scenario where, or at least within the healthcare side, we are seeing where it's a combination of form understanding and then the question, Or there is a third scenario where you have a combination of image understanding and then taking a decision, and then doing question answering, where you have images of certain, let's say, people with certain kinds of diseases, and then the model, the vision language model, would have to understand what kind of diseases are present in this image, and then potentially generate a report out of it. Think of what Google is doing with MedPalm 2, or some of the use cases related to MedPalm 2. That's where we are seeing a lot of generative AI applications within the healthcare industry.
I just think, so I know, Yeshwanth, you mentioned Sora. Do you think there's any sort of, I'm guessing, the dangers of videos like that?
Yeah, we are walking on eggshells right now. Yeah, really, we need to, we are at a point where I think around 4 to 5 years back, there was this term called as fake news that really took flight, right? So we are at a time where no matter what thing we see on the internet, we just need to be vigilant and need to question ourselves whether something is right or wrong. It can go both ways. There could be things that we see which are real, but we need to maybe question ourselves, maybe it is fake, and the other way around. So as long as we have a vigilant mind right now, I think we are on sort of the safe side, but really I don't think there are any proper what do I say recipes that clearly tell something is real or fake as of now. Maybe they can come from visual cues. Maybe they will be sort of obvious in some models, maybe not that obvious in some models, but as long as we are aware that these are the things that are happening more and more day by day, I think the only way is to be vigilant and keep questioning the source material.
Yeah, there will be potentially two stages of dangers here, Bhavesh. The first one is obviously the videos getting ultra realistic. At least at this point, Sora is almost there, but I think in 6 to 12 months down the line, whenever they release it, it will be very difficult to differentiate between the two. The second stage of danger of this one is it happens to be when this happens real time. For example, if one of the problems with or one of the blessings, I would say, that we would see is it takes considerable amount of compute in order to generate a video. So that cannot happen real time. But the day when the models become small enough that this can be done in a real time on a real time basis, that's when the dangers are even more grave, and that would be the scenario to be really worried about.
I guess on the positive side, as you mentioned, healthcare benefits, like I'm guessing, can you spot diseases earlier? And
yeah, I think at least in healthcare, one of the good things that's happening is whenever you are taking a decision, you really want a human to validate the decision, and not necessarily always go with the model. Over there, within healthcare, you have a human who is either agreeing or disagreeing with the model and using that, giving that as a feedback loop for the model to further improve upon. So as long as we are not taking automatic decisions, I think we are just fine. We're improving the operations efficiency. But the moment we are going to take automatic decisions, that's when we need to be really careful about the corner cases.
Thanks for that. Wilma, the video will be available after the live session. I wasn't sure if you wanted the transcript. I can check on that if that's what you want. And then, I say, please feel free to add questions and enter the raffle. So So the third question I've got is, when do you leverage foundation models or generative AI over model fine-tuning?
Yeah. Yeah, sure. I'll give my perspective. You just try both, sort of. First, given the advantage of foundational models having zero-shot capability, I would say that should be the first thing you should try. And only when you know that it's failing in considerable amount of cases, do you have a use case to fine-tune your own model, whether it is adding some adapters, or you have a new technique called as low rank adaptation, which really speeds up the training. So yeah, the recipe is straightforward. Use what you have it in your hand. If it doesn't work, then try to experiment. Unless you have a very niche use case where you know that something is not going to work well in advance, primarily because of the difference in the domains of what you are using and what it has been trained on. So for example, you can't use let's say an ImageNet model on maybe this is on medical reports, right? So you need to be aware of certain things while using a foundational model. But I would say in this day we are really blessed with zero shot capabilities, and that should be the first thing to try.
Yeah, and also when we are thinking about foundational models, while there are foundational models that are specific to computer vision, there are a certain set of other foundational models. Think of image bind for a moment, where you have different modalities that can be combined together. So think of text, audio, video, and images can be combined together in order to achieve certain tasks. So again, the second thing that we also have to think about is the kind of modalities that we are dealing with. And when it is a multi-model data, generally, unless you're leveraging a good pre-trained model, working or fine-tuning a multi-model data would require considerable amount of data. A multi-model model would require considerable amount of data. So that is where the idea is, think about what are the different modalities that you're going to work on. And then the second one is, you might also want to think about the aspects around cost slash latency of the model. There might be scenarios where if you're leveraging a foundational model that is fairly large, then you will have to incur a lot of cost with respect to the GPU that you're working on, versus if you're working on a smaller model. Think of the traditional models with let's say 10 to 50 million parameters. That's when the cost is going to be considerably lower when compared to working on the models with billions or hundreds of millions of parameters. So the other thing that you will have to think about, apart from the kind of data and the amount of data that you are working on, is the latency and the cost aspects of productionalizing or using the model. So I would say these are the three major considerations that I would think about when deciding between whether it is the foundational model that I'm going to work on or whether I'm fine-tuning a model.
I mean, would there be a scenario where you might want to pre-train a model? So sort of.
Yeah, again, for example, I can give us an example that we have worked on very recently on a different project, where it's essentially OCR, but then within OCR, we are expected to identify subscripts. For example, we have a letter that is 6 subscript 8. And if you think of it, while all of these are numbers, you'll have to figure out what is a subscript versus what is not a subscript. So in that case, what we have done is, obviously we went ahead and generated different types of data or types of images with a bunch of subscript and non-script information, and then built a model on that synthetic data. So it all boils down to how much of a synthetic data that you can generate that looks closer to your realistic data, and also how much data do you have access to.
Excellent. I think the first draw now. So if anyone wants to do a join, just type in hashtag Pat. And So I'll do the first draw. It says Asim Shah, congratulations, you're the winner of the first ebook. And yeah, if you can just send me a LinkedIn message with your email address, and I'll get that ebook to you. Okay, so how deeply should one understand under the hood of algorithms in the age of sort of ChatGPT and Claude?
Yeah, I think it's an interesting question. I think we're essentially living in the year and also in future where you have all or a majority of the required information that is available through the different models, be it ChatGPT or Claude. I think if there is the way I would always look at it is one. I would like to understand, just like how I started with the motivation for writing my book. I would really think about how is it that the author is explaining this topic, because I would, as a data science or as an AI practitioner, I would really be keen to understand how different people approach in solving a particular problem, and a book essentially gives you the perspective of how the author is thinking through about solving a problem, and also it gives you the perspective of how about their perspective of how different models work or what happens under the hood of the different models. So I'd say while ChatGPT is great, while ChatGPT gives you great answers, a book essentially gives you a peek into the minds of the authors, helping you understand what they have gone through and the pitfalls that one has to avoid in order to arrive at the answer.
Yeshwanth, do you want to add anything?
How deep or how important is it to understand the core concepts? I think it's a function of what you're trying to do, right? Back in my days of back when I was not even born, there were still advanced developments, right? There was a time when people used to think, oh, we just invented calculator, now we are going to run out of jobs, right? So it's always yes, advances will keep happening. If your motivation or goal is to just use those tools, I think high level understanding will be sufficient. Maybe understanding level 1 or 2 might be sufficient. But if your pain point is, I really want to come up with something fresh, these are the things where model is limited, maybe I want to change something in the model, that is when you need to really dig deep and understand how to build something from scratch. So it's a question of motivation, it's a question of necessity. So the moment you have those sorted out, I think you'll naturally aspire and seek more.
So I think in the book you build a lot of models from scratch, don't you?
Yeah.
So do you think that that's an important to help people understand basically how the models work in? And
Of course. Back when we wrote the first edition, there were no such foundational models. So it was a natural task of creating as many models as possible for the sake of understanding the components. Like you said, chapter 1 and 2, they speak about what are neural networks, but unless you get your hands dirty, it's impossible to really get a feel of them, which is why we had so many experiments and models from scratch. Every model that has been written from scratch will have a something unique about it, whether it is in the last loss function, whether it is in the architecture, whether it is in the way we inject the data. Every model had its own uniqueness, right? So the goal of having those applications written from scratch, I would say, was to give a holistic understanding of where we are and how to do anything, even in the future when, let's say we covered 50 applications, but there is a 51st application that someone wants to solve. We hope that, these 50 will give them an idea of which tool to pick, which concept to pick from one of those 50 and apply them. Right. So when it came to the second chapter, it was a whole different beast, primarily because nobody can train that much in a limited amount of time, especially two people. I don't think it's a fair ask for either of us to come up with foundational models from scratch. So it was a nice change in pace, and a reason also to come up with a second edition, which is, hey, we built so many things from scratch, but like you said, given the day where we have such powerful models, why not just use them, right? So I think second edition has the benefit of showing both the sides of the coin. Whether you want to really tinker deep, you just go through the first n chapters. No, I just want to use something that is already available. That's what we cover in the last few chapters.
Is there a benefit in terms of cost or building something from scratch, you feel, as well? Or is it purely for the learning side?
I think Kishore can have a better answer here, but whenever you're trying to do something from scratch, yeah, it's definitely a affair of cost and time and labor.
Yeah,
Kishore,
I think the way I would look at it is obviously it's going to cost considerably if you're trying to build from scratch. It's, as they always say, build on top of giants, or the work that was done earlier. So always go ahead, leverage what is there, and build on top of it. But the reason why you would really want to build from scratch is not to build a better model, but to really understand what is happening within the model, or what are some of the areas where the model works great and where the model does not work as well. So I think the takeaway here should be, once I know that this is how the model is working, then you have a very good understanding of the model, and the inputs and the corresponding outputs. That's when you sort of work on top of the giants, or work on top of the previous work, and extend the use cases, or extend the capabilities of prior architectures or models, and build newer ones that will be further used by others.
Thanks. So, yeah, everyone, feel free to add your questions to the chat. So my next question is, so what aspects do you consider while deploying models?
Yeah, I think as I mentioned, for example, when you're deploying the models, the first thing that you're thinking about is how accurate is my model on real world data. For example, so far you might have tested your models based on the data that you have access to, and one of the examples that I can think of is a scenario where where a fairly large company was testing out their cataract detection related model in some of the clinics in a certain place. And while it worked great theoretically within the labs of this company, when they deployed this model in within the clinics, that's when they have not seen that the models are not accurate. And when they went ahead and tried to understand why the difference, or why the delta in accuracy is, and they have figured out that the lighting conditions that are there at this particular clinic vary considerably to the lighting conditions that are there at in the labs of this large company. So that is where, especially when you're dealing with neural networks, or deep learning models, you'll have to really think about, is my real world data as close to my training data as possible, or if there is a drift. So potentially the first thing that you're thinking about is accuracy and the drift of the real world data. The second one that you're also thinking about is, as I've mentioned earlier, if you are dealing with fairly large models, again, we've all seen that as models grow large, their generalization capabilities also increase considerably. But at the same time, while the models are large, the cost associated with the deployment or the inference of these models is also going to be quite high. So you'll have to think about how do I go about maintaining my infrastructure for an increasing load or for the given load at an optimal cost. So at that point in time, you'll have to think about, is it really worthy for me to have a fairly large model versus could I have maintained with a smaller, not a language, but let's say a vision model. So again, these are the two major considerations that I would have, primarily around accuracy/drift, and then the cost associated with managing and maintaining these models.
Can you anticipate drift before going live with a model?
I think you can, to an extent, as I mentioned earlier. For example, had this company known about or simulated the scenario of the clinics that are there in the real world, they would have probably leveraged some of the data augmentation techniques in order to make the image as closer to a real world image as possible. So in a way, you could have trained your model leveraging data augmentation to mimic the real world scenario. But then again, that might be clinical one. What about in a clinic two, where you might have, instead of lighting conditions variation, you probably have a resolution difference between the cameras that were used in the training data versus the camera that is there in clinic number two. So in that particular case, you would have to know that there is a potential resolution issue that is happening in clinic number two. So I would say, before even deploying, you would probably test it out in multiple clinics, try and understand what are the scenarios that are there or what are the edge cases, and then generate either leverage data augmentation or generate synthetic data that can address those scenarios or that can cover those edge cases in order to get those scenarios correctly. And by the way, go ahead. This is all covered in the sixth chapter, where we are talking about some of the practical aspects that we need to consider while deploying the models.
Yeah, just gonna say, like, how do you create the synthetic data to
Yeah. For example, in the scenario that I mentioned, where you have to generate a bunch of subscript or the numbers and the corresponding subscripts, that's when it's way easier when you're generating synthetic numbers or synthetic, let's say, OCR related text. But when you're trying to generate synthetic data corresponding to, let's say, cataract images, just for a moment, then potentially you would leverage some sort of autoencoder related autoencoder techniques in order to generate images that are similar to your training data. Think of, let's say, your GANs for a moment, or think of, again, diffusion models for a moment, where you have a bunch of data and you're trying to generate another set of data that resembles the bunch of data that you have, or that resembles a subset of the data that you already have.
So I'm guessing there's a feedback loop with the live data. So does that then fine tune the models?
Yeah,
or
the feedback loop would also involve some level of quality assessment in here, because when you're generating data, you don't want to have a pipeline that automatically generates data and then goes ahead, fine tunes the model without any human validation. So ideally, for the data that is generated, you really want a human to validate, or some mechanism to validate that here is a data that is actually good and that can be used in order to further fine tune my model. And only when it passes through that gate, and again, there are different ways of figuring out how to figure out which synthetic images need to have this gatekeeper mechanism versus which are the ones that can be used straight away. But think of, you have a larger model that is saying this is a good image versus this is an image that you really want someone to validate. So again, it could be a human, it could be a reinforcement learning using AI, but essentially a mechanism to figure out the good quality data that goes into the fine-tuning process.
So the next question is, so I think we just touched on it earlier. So which industries are really benefiting from computer vision?
Yeah, as I mentioned, I think as Yeshwanth mentioned already, entertainment/movies are already there. I think even in the traditional computer vision days of the world, where there would be, let's say, the I would say human annotators or graphics designers who are essentially segmenting people and then overlaying background image on top of the segmented people. Now, what we are seeing is segmenting a person is fairly straightforward when you are leveraging, let's say, a foundational model. That is step one. And then once I identify the person, let's say using segment anything model just for a moment, then I can always consider the remaining part that is not the person as the green mat just for a moment, and can overlay anything that is of interest to me. So essentially, what used to take considerable number of man hours in order to do this background matting by having humans identify the objects of interest or the subject of interest and then keep it in the foreground while replace the background, is now automatically done using AI. So that's the most obvious use case that has benefited from the latest in computer vision. And then the second one that we are already all aware of is around the self-driving revolution that is happening, where you're talking about self-driving cars that potentially do the majority of the navigation. 95%, again, this percentage varies based on the conditions, be it the place where we are as well as the atmospheric conditions at that point in time. But then self-driving car is the second scenario that we are looking at. And then the third scenario that we are looking at is more around surveillance, where you're trying to look at what are some of the scenarios where, for example, in surveillance, there are techniques that identify objects of interest, but then there are also techniques that have come in more recently that recognize certain actions. So now, if there is certain kind of, let's say, the violence that is happening at a certain place, or if there is a fall that is detected of a person, there are so these models would detect the event based on the sequence of frames or based on the video, and then send an alert saying here is where the event has happened, which was not enabled earlier. But again, given the advances, so we have moved on from just looking at a single frame, but coming to a decision based on a sequence of frames. So these are the three that come to top of my mind, apart from the one that we have discussed so far. Yeshwanth, anything else?
Yeah, on top of safety, I would also want to tag accessibility use cases where there is a person with visual impairment, or you are in a factory where you might not have good visibility on all the machines. These are the kinds of cases where you're not exactly talking about safety, but nonetheless you're still trying to see the world through the lens of a computer, where you yourself cannot employ your own faculties, right? So accessibility, I think, is also one use case where things need to pick up, and I think they are picking up.
Do you see any sort of maybe use cases in the future, 5 years down the line, where you think actually this could be like a new growth area for computer vision?
Sorry, I could not hear you properly, Bhavesh. Can you repeat the question?
Oh, yeah. I just asked if do you feel there might be some new use cases in 5 years' time that there might see a big growth in sort of computer vision?
Okay. I think that when we are talking about the kind of use cases that will be there in future, I think the biggest one that I can think of at this point is more around the combination, or think of your mixed reality and the virtual reality related use cases, Bhavesh. So I think those are the ones that are very likely to happen fairly soon. More so because one, the models are already there, and then and also the aspects around be it the image models or computer vision models, and also the language models are already there. I think the next bigger use cases are going to be around mixed reality, both in terms of the immersion in a virtual world, but also in terms of 3D aspects related to that, where you can Google has already demoed some of their products, or at least that are in their works, where you can feel the person is sitting right next to you or right in front of you. But there is a very good chance that those will be the set of use cases that will be the ones that will be the major ones in the near future. Anything else that you see, Yashwant?
Yeah, the mixed reality point, actually, I was incidentally looking at an NVIDIA paper today, and it turns out they have a capability where they can literally scan an entire city and reproduce it using, I think, around 10 A100s. So that's around 800 GB of compute, and they were able to reproduce an entire city in as a virtual world. So I believe it's going to be really interesting if we can come up with capabilities where people start living in virtual worlds. There are actual cities, and you have real estate in the city, and it is really interesting.
And so I've got another question on sort of how do stable diffusion models work?
Was that the question? Sorry.
Yes, yeah. How do stable diffusion models work?
Chapter 16, section 3.
Yeah, I think at a very rough level, the model it's a okay. I'll put it this way. You know how they say ChatGPT is just autocomplete on steroids, right? Right. Yeah. So in a similar fashion, I think stable diffusion is just a denoiser on steroids. So it really knows how to remove the noise, how to separate the noise from the signal, and it keeps doing that again and again, and that's how it arrives at really stunning pictures or videos.
As it differ to like a GAN then?
Right. GAN conventionally tries to do the entire generation in one shot. It's trying to map. Here is noise. Here is my actual domain distribution. Can I just go from one end to the other with a single forward pass? And in the process of coming up with a good, domain mapper, that's what I would try to say. It's a domain mapper. In the process of coming with a good model, you try to employ techniques like another auxiliary model that is trying to help again a generative model trying to see whether something is good or bad. Like a child trying to learn an alphabet from just random scribbles. There have been historically a lot of troubles with GANs. There's stuff like domain collapse. It's a very classic problem where it just tries to give the same image as any other image. It just gives one image and says, this is all I can do. Stuff like that have really pulled back GANs. It was a nice technique, but people always try to work around it with some minor tweaks. Whereas diffusion was a completely rework of what a GAN is trying to do. GAN is trying to jump from pure noise to pure signal. Diffusion models are you're trying to give a leeway. Here is little noise and little signal, just try to do a slightly better job. That significantly reduce the burden on diffusion models, and that is why you really came up with so many different use cases, right? So the moment you I think this is a good lesson in how you're trying to formulate the problem in the right way, because both GANs and diffusions are trying to do the same thing, which is given noise, try to come up with something meaningful, right? So it's a really good lesson in formulating or breaking down the problem into sub problems. And I think yeah, uh, stable diffusion or diffusion in general is trying to ease the model's burden. And yeah, I think that's why you see so much success there.
Yeah, and also to an extent, a good amount of pre-training that is done leveraging stable diffusion. Again, think of scenarios where you're combining, again, multiple modalities. Think of generating text along where you give noise as an input, and also generating image where you have noise and text as an input, or generating image where you have noise, text, and then let's say the open pose or some canny image of what you're trying to generate, or a reference image. So essentially, when here you are talking about combining multiple modalities, at the same time you're also talking about pre-training the models so that I can generate data with as limited or I can generate data in a zero shot setting.
Have you seen any models that might be performing better than diffusion models?
Yeah, current rage is not diffusion right now. People are talking about flow transformers. Stable diffusion 3 came out, I think, a month ago, and that is on top of using standard stable diffusion. It is also using a slightly different technique where instead of trying to go from point A to B, so there have been papers where stable diffusion was proven to be a slightly inefficient. So the flow matching models, they sort of try to denoise in a much more efficient and faster way. So this is sort of going back into the sort of like the territory of GANs, where you're trying to do more in less time, but the paradigm still remains the same. And yeah, currently even Sora, I think the large success was attributed to the flow matching. Yeah, so I'm definitely sure there will be even more awesome techniques going down the line. But I believe we hit a good nail, I would say, where we found a fundamental paradigm of trying to do as trying to make the model do as little as possible, while trying to get as much out of it as possible. So what I'm trying to say is, this is a very sort of a natural way to generate images. I think we hit a good uh, uh, flow, I would say. Maybe the internal details might keep changing in the middle, but I think somehow, like, largely CNNs got stuck. I would say diffusion is sort of the go-to way to tackle image generation cases. I think it will stick for a long time.
Kishore, anything to add to that?
I think just like what we have seen, transformers have been there for quite some time, and then the different variants of transformers or different ways of leveraging transformers are emerging over time. So for example, earlier we were thinking about transformers that will do only machine translation, and then we have figured out that using transformers we can do multiple tasks and not just the encoders and the decoding part. So I think again the backbone is going to be same, be it transformers or be it the unit that we are currently using, but then the workflow around that one, for example, even in the generation of text to video space, where the backbone architecture at a high level remains the same, but the way in which we are tweaking the model slightly in order to achieve for this particular task is changing. So I would think that it still is going to remain the same, but then the workflows are going to be slightly different, as well as the data that is used to train these models is going to be slightly different, which will come up with a newer model and hopefully a better model.
Excellent. So I think we'll do our final draw for the book giveaway. Okay. So we'll just do a draw again. So the winner is Ashwin Kumar. Ashwin, if you could just send me a message on LinkedIn, and send me your email address on LinkedIn, and I'll send the ebook to you.
Congratulations, Ashwin.
And so thanks for both of you joining me today. That was a very insightful session. And as everyone, we'll see you next live session.
Thank you, Bhavesh. See you soon. Bye-bye.
Thank you, Paresh.